Hey there, science fans! Have you ever stopped to think about how much we rely on electricity? It's everywhere. It lights up our homes, powers our devices, and even cooks our food. Imagine a world without electricity. No smartphones, no internet, no refrigerators. Life as we know it would grind to a halt. But have you ever wondered where this amazing energy source comes from? And how does it actually work? Get ready to explore the fascinating world of electricity. We'll uncover the science behind the current, from its discovery to its impact on our planet. Buckle up, it's going to be an electrifying ride. For centuries, electricity remained a mysterious force of nature. Ancient civilizations witnessed its power in the form of lightning, but harnessing it seemed impossible. Then came the pioneers of electrical science. Benjamin Franklin, with his famous kite experiment, proved that lightning was indeed electrical. This groundbreaking discovery sparked a revolution in scientific thought. Later, brilliant minds like Thomas Edison and Nikola Tesla paved the way for practical applications of electricity. Edison's invention of the light bulb illuminated our world, while Tesla's work on alternating current, or AC, revolutionized power distribution. So what exactly is electricity? The answer lies in the fascinating world of atoms. Everything around us, from the air we breathe to our own bodies, is made up of tiny particles called atoms. Atoms have a nucleus at their center, containing protons, which are positively charged, and neutrons, which have no charge. Whizzing around the nucleus are even tinier particles called electrons, which carry a negative charge. Electricity is simply the flow of these electrons from one atom to another. Now that we understand the basics, let's explore how we generate electricity on a large scale. This process is essential for powering our homes, businesses, and industries, ensuring that we have the energy we need to live our daily lives. This is where power plants come in. These facilities are the backbone of our electrical infrastructure. Think of them as giant factories that transform different forms of energy into electricity. They are complex systems that require precise engineering and skilled operators to function efficiently. There are several types of power plants, each utilizing different energy sources. These sources can range from fossil fuels to renewable energy, each with its unique method of generating power. Some of the most common ones include coal-fired power plants, which burn coal to heat water, producing steam that spins turbines connected to generators. This method has been used for over a century and remains a significant source of electricity worldwide. Natural gas power plants, similar to coal plants, burn natural gas to generate steam and spin turbines. They are often considered cleaner than coal plants due to lower carbon emissions. Nuclear power plants use nuclear fission, the splitting of atoms, to release heat, which is then used to generate steam and power turbines. This method produces a large amount of energy from a small amount of fuel, making it highly efficient. Hydroelectric power plants harness the energy of flowing water by using dams to create a height difference, driving turbines. This renewable energy source is one of the oldest and most reliable methods of generating electricity. Wind farms utilize wind turbines with large blades that capture wind energy and convert it into electricity. These turbines are often located in areas with consistent wind patterns to maximize efficiency. Solar farms use photovoltaic cells to convert sunlight directly into electricity. This method is becoming increasingly popular as technology improves and costs decrease. Each type of power plant has its advantages and disadvantages, but they all share the same goal: to keep the electric current flowing. By understanding these different methods, we can appreciate the complexity and importance of our electrical grid. Section 5. Coal-fired plants, the legacy powerhouses. These monumental structures have been a cornerstone of industrial progress and energy production for decades. Let's take a closer look at coal-fired power plants. These facilities are complex and fascinating, with intricate machinery and dedicated engineers ensuring their operation. These plants have been the backbone of electricity generation for over a century. From their inception in the late 19th century, they have powered homes, industries, and cities, driving economic growth and technological advancements. They work by burning coal in a furnace to produce heat. This process involves pulverizing the coal into a fine powder, which is then ignited to release its stored energy. This intense heat boils water in a boiler, creating high-pressure steam. The boiler is a critical component, designed to withstand extreme temperatures and pressures. The steam then flows through pipes to a turbine, a large rotating machine. The journey of steam through these pipes is a marvel of engineering, ensuring minimal heat loss and maximum efficiency. As the steam expands and cools, it pushes on the blades of the turbine, causing it to spin rapidly. This spinning motion is the heart of the power generation process. The turbine is connected to a generator, essentially a giant magnet surrounded by coils of wire. The precision engineering of these components ensures a seamless conversion of mechanical energy into electrical energy. When the turbine spins the magnet, it creates a flow of electrons in the wires. This is electricity. This electricity is then transmitted through power lines to homes and businesses, lighting up our world and powering our lives. Section 6. Natural gas plants. A cleaner burn. Natural gas plants operate on a similar principle to coal plants, but they burn natural gas instead of coal. Natural gas is a cleaner burning fossil fuel than coal, meaning it releases fewer pollutants into the atmosphere. However, natural gas is still a fossil fuel, and its extraction and transportation can have environmental impacts. Despite these concerns, natural gas plants are often seen as a bridge between dirtier coal plants and cleaner renewable energy sources. Section 7. The nuclear option, power from atoms. Nuclear power plants are a unique breed. They don't burn anything. Instead, they harness the immense energy stored within the nucleus of an atom. This process, called nuclear fission, involves splitting the nucleus of a heavy atom like uranium. When the atom splits, it releases a tremendous amount of heat, which is used to generate steam and spin turbines, just like in coal and natural gas plants. Nuclear power plants are highly efficient and don't produce greenhouse gases during operation. However, they generate radioactive waste that requires careful management and disposal. Section 8. Harnessing the elements' renewable energy. Now let's talk about renewable energy sources, the future of electricity generation. Unlike fossil fuels, which are finite and contribute to climate change, renewable sources are constantly replenished by nature. Solar energy harnesses the power of the sun, while wind energy captures the kinetic energy of moving air. Hydroelectric power utilizes the flow of water, while geothermal energy taps into the Earth's internal heat. Renewable energy sources offer a sustainable and environmentally friendly way to power our world. As technology advances, these sources are becoming increasingly efficient and cost-competitive with traditional fossil fuels. Section 9. The electric highway, from plant to power outlet. We've seen how electricity is generated, but how does it get to our homes and businesses? The answer lies in the power grid, a vast network of transmission lines, substations, and transformers that act as an electric highway. Once electricity is generated at a power plant, it's stepped up to a very high voltage using transformers. This high voltage allows electricity to travel long distances efficiently with minimal energy loss. The high voltage electricity is then carried by transmission lines, those tall towers you often see crisscrossing the landscape. These lines act like the highways of the power grid, transporting electricity across states and even countries. Section 10. Electricity at home, a distribution network. As the high-voltage electricity gets closer to our homes, it needs to be stepped down to a lower, safer voltage that our appliances can handle. This is where substations come in. Substations are like off-ramps from the electric highway. They house transformers that lower the voltage to a level suitable for distribution within neighborhoods. From the substation, electricity travels through smaller distribution lines to our homes. Inside our homes, electricity flows through a system of circuits, each protected by circuit breakers. These safety devices act like electrical guardians, interrupting the flow of electricity if there's a surge or overload, preventing damage and fires. Section 11. Powering progress. Electricity's impact on the world. Electricity isn't just about keeping the lights on. It's the lifeblood of modern society. It powers our homes, fuels our industries, and enables countless technological advancements. In healthcare, electricity enables life-saving medical equipment, from X-ray machines to ventilators. In education, it powers computers and projectors, opening up a world of knowledge. In industries, it drives machinery, automates processes, and increases productivity. Electricity has transformed the way we live, work, and interact with the world. It has brought light to darkness, connected us across continents, and fueled unprecedented economic growth. Section 12. The Energy Divide, Challenges and Opportunities. While electricity has brought immense progress, it's essential to acknowledge that billions of people worldwide still lack access to this vital resource. This energy divide perpetuates poverty, hinders development, and exacerbates inequalities. Many factors contribute to this disparity, including geographical challenges, limited infrastructure, and economic constraints. However, there are also tremendous opportunities to bridge this gap through innovative solutions and international cooperation. Off-grid renewable energy systems, such as solar home systems and mini-grids, offer promising solutions for remote communities. By empowering these communities with access to electricity, we can unlock their potential and create a more equitable world. Section 13. Electricity's Future, a Call for Sustainability. As we look to the future, it's clear that electricity will continue to play a pivotal role in shaping our world. From powering our homes and businesses to driving technological advancements, electricity is the backbone of modern society. However, we must transition towards a more sustainable and equitable energy system. This transition is not just a necessity, but a responsibility we owe to our planet and future generations. This means embracing renewable energy sources, improving energy efficiency, and investing in innovative technologies that reduce our carbon footprint. It also involves ensuring universal access to electricity, so that everyone, regardless of their location or economic status, can benefit from this essential resource. Addressing the challenges of climate change is paramount. The effects of global warming are already evident, with melting glaciers and rising sea levels threatening ecosystems and communities. Reducing our reliance on fossil fuels is crucial. The continued use of coal, oil, and natural gas not only depletes finite resources, but also contributes significantly to greenhouse gas emissions. The future of electricity is in our hands. By making conscious choices, supporting sustainable technologies, and investing in renewable energy projects, we can drive the change needed for a greener future. Advocating for responsible energy policies is equally important. Governments and policymakers play a critical role in setting regulations and incentives that promote clean energy and discourage harmful practices. By working together, we can create a brighter, more sustainable future for generations to come. Every small action, from using energy-efficient appliances to supporting clean energy initiatives, makes a difference. So the next time you flip on a light switch, take a moment to appreciate the wonder of electricity and the complex systems that bring it to you. Consider the countless people and innovations that make it possible, from engineers and scientists to policymakers and activists. Let's work together to ensure that this powerful force continues to illuminate our world for generations to come. The journey towards a sustainable energy future is a collective effort, and every step counts. Together, we can harness the power of electricity to build a world that is not only brighter, but also more just and sustainable for all. Stay curious, tech enthusiasts, and keep exploring the digital world.